Hello everyone, welcome to my YouTube channel. Today we will discuss evaluation of analytical data of potassium dichromate in terms of precision. Introduction. A scientist always worries about the quality of analytical result, whether these results are obtained directly by him or from someone else. He always thinks that the results should be good. Statistically, calculations are necessary to understand the significance of the data that are collected and therefore to set limitations on each step of analysis. The methods used by scientists in evaluating the significance of analytical data with the knowledge of normal distribution of errors in terms of probability. We shall also see how the precision of measurements can be determined. Theory. There is always a certain amount of potential error in each step of chemical analysis. Error can be classified generally into categories of determinate and indeterminate error. Determinate error. Determinate error is due to some specific cause, so magnitude of this error can be reduced or eliminated. It is also known as systematic error. Determinate error is measured in terms of accuracy, which is the degree of agreement between the measured value and the true value. Indeterminate error. Indeterminate error has usually no specific cause, so magnitude of this error cannot be eliminated. It is also known as random error. This error leads to scattering of results around the actual value. Indeterminate error is measured in terms of precision. Causes of random error. Electronic noise in the circuit of an electrical instrument, temperature fluctuation, vibration and drafts that cause small variation in the balance reading, visual judgments such as level of the water with respect to the marking on the pipette and the mercury level in the thermometer. Precision. What is precision? Precision refers to the closeness of two or more measurements to each other. For example, if you weigh a given substance 5 times and get 3.2 kg each time, then your measurement is very precise. Precision includes repeatability and reproducibility. Repeatability is the variation arising when all efforts are made to keep conditions constant by using the same instrument and operator, repeating during a short time period. Whereas reproducibility is the variation arising using the same measurement process among different instruments and operators over longer time periods. These figures represent the increasing and decreasing order of precision and accuracy. Figure number 1 shows high precision and low accuracy, in which all results are close together but not consistent with the true value. Figure number 2 shows high precision and high accuracy. All the points are close together and average around the true value. Figure number 3 shows low precision and low accuracy. This is neither precise nor accurate. This is pretty much how it looks when I am shooting. No consistency, not equidistant from the center, just random. And finally, figure number 4 shows low precision and high accuracy. The results are around the true value but not too consistent with each other. Now, standard deviation. There are a number of measures of precision of replicate analysis, but the most preferred parameter as an estimate of precision of analysis is standard deviation. Here is the formula of standard deviation, where S is the standard deviation, AI is individual measurement, A is mean value, and N is the population size or number of measurements. Standard error is also the part of the theory. It is very similar to standard deviation. Both are measures of spread. The higher the number, the more spread out your data. The two terms are essentially equal, but there is one important difference. While the standard error uses static sample data and standard deviation use parameters population size. Here is the formula of standard error, in which standard error is equal to the standard deviation upon under root n, where n is the population size. This formula tells us that the standard error of the mean is smaller when the sample size is large. This is true for standard error in general. In this section, only a brief description of instrumental features will be mentioned. We perform our experiment on UV visible spectrophotometer. Here is how a spectrophotometer works. A lamp provides a source of light. The beam of light strikes a diffraction grating, which works like a prism, and separates the light into its component wavelengths. The grating is rotated so that only a specific wavelength of light reaches the exit slit. Then the light interacts with the sample. From this point, the detector measures the transmittance and absorbance of the sample. Transmittance refers to the amount of light that passes completely through the sample and strikes the detector. Absorbance is the measurement of light that is absorbed by the sample. The detector senses the light being transmitted through the sample and converts this information into a digital display. Now moving towards the procedure. zero point 0.9 gram of potassium dichromate was accurately weighed and completely transferred to a 250 ml volumetric flask, acidified with 3 ml of H2SO4, and then made up the volume of the flask with distilled water. This is the primary stock. 10 ml of primary stock solution of potassium dichromate was transferred to a 100 ml volumetric flask, and the volume of the flask was made up with distilled water. This is the secondary stock. 3 ml of secondary stock solution of potassium dichromate was transferred to a 25 ml volumetric flask, and the volume of the flask was made up with distilled water. This is the working standard. A blank solution was prepared by adding 2.5 ml of H2SO4 to another 25 ml of flask, and the volume was made up with distilled water. 2.5 ml of the given sample solution was transferred to a 25 ml volumetric flask, and 2.5 ml of H2SO4 was added to the flask, and the volume was made up with distilled water. Instrument was set at 440 nanometer measurement mode, and the baseline was corrected using blank solution. Note down the absorbance of both solutions, working standard and sample, at 440 nanometer on single beam spectrophotometer. The concentration of the sample solution was calculated in molar by using the working standard by applying single point formula. Replicate analysis of the sample solution was performed. The precision of the replicate analysis of sample was determined by using standard deviation formula for molar concentration. Standard error of the analysis was determined by using the standard error formula. Now observations. Absorbance of working standard is 0.374. Absorbance of sample is 0.405. Operating wavelength is 440 nanometer. Concentration of working standard is 1:10⁻³ molar. Readings taken on instrument are given below. Our calculation involves 7 steps. Result. The standard deviation of the replicate analysis of potassium dichromate in molar concentration is 5.9672 exponential minus 5. The standard error is 1.8869 exponential minus 5.